I wanted to create this webinar for a long time. This webinar is from engineers by engineers. For the last few years, myself and all the engineers panel from Hirose have talked to the customers to see their concerns. We have discussed these connectors. This is the voice that you have mentioned. These are the list of concerns. We have grouped these concerns in 5 buckets. One is applications. Is this connector just for displays? How about the robustness for design and manufacturing? How easy or difficult is to assemble? How you manage the cable? And finally, what features do you have to meet the current requirements? Let's talk about some of the experience from our panel. Liam, Kerrick, Neral, thanks for joining us today. And let's start with you, Liam. Tell us about your customer experience.
Hello, everyone. So I am based out of New England. I'm based out of Massachusetts. In my experience with Hirose, I've worked extensively with many industrial and robotics customers here. And there's also a strong focus for the medical market here in New England.
Thank you, Liam. Kerrick?
Hi, guys. I just want to say I love my job. So over the past 6 or so years, I've been traveling with hundreds of customers. And so I get to learn about, the common challenges or the unique challenges that each customer has. That includes specifically, I lived in Detroit for a while and worked with some large automotive customers.
Thank you. Neral?
Hi, everyone. My name is Neral. I live in Chicago in the Midwest, and I see a lot of customers from automotive, industrial, and consumer electronics. And I've gotten a lot of good experience and a lot of customers using different connectors.
Thank you. We're also joined by Jay. Jay, tell us about Miraco, your customer base, and your experience.
Yeah, so Miraco, we design and manufacture custom interconnect solutions. We have a primary focus on flexible printed circuits and flat flexible cable, which of course is relevant to this webinar. We do serve all industries. However, our primary focus seems to fall on medical devices and also the military and in aerospace industries.
And Jake, how long have you been using Hirose connectors?
Oh, I've been using Hirose connectors since pretty much the day I started at Miraco for over 26 years.
Wow, thanks. There's a long history of flex connectivity. In the 60s, you used to have direct soldering from the flexible circuits to the PCB, some cases using a hot bar. There's been some changes over the years, and in the 1990s, Hirose came out with the hinge actuator, which is the most prevalent design nowadays. But the innovation didn't stop there, as you'll see through the webinar. By the way, we're going to focus on commercial, industrial, medical, and automotive applications. They require a little larger connectors. Let's begin with talking about some of the fundamentals. Jay, can you walk us through the type of flex cables?
Certainly. Yeah, the first one there, a flat flexible cable, also known as FFC, is a cable consisting of straight parallel runs of copper conductors that are loomed and laminated together. The middle one, flexible printed circuit, also known as FPC, are also extremely flexible like FFC. However, they're a print and etch process. So think of it like a printed circuit board that you can bend and flex. And then the third one there, carbon ink circuit, a lot of folks know those also as membrane switches. They are a screen printed type of circuit using a conductive ink. Again, very flexible. You'll primarily see those used in graphic overlays on appliances and such.
And Jay, for the application we're talking today, what's more popular, FFCs or FPCs?
Overwhelmingly, FFC is more popular because of the scale of economics and the low costs.
And the common pitch is 0.5, right? 0.5 millimeters?
Yeah, absolutely. The FFC, 0.5 millimeter pitch is the currently the tightest pitch that's available for FFC as a standard product.
And finally, what drives the cost of an FFC?
The size can really drive the cost on these, depending on the number of conductors and the overall length.
But it doesn't necessarily increase linearly with the number of contacts, right? Because there's a fixturing setup cost.
Yes, that's very true. Once this is set up, these things can run unmanned in an automated fashion.
Okay, thank you. Let's switch to talk about connectors. Kerry, walk us through some of the basic concepts for this type of connector.
Right. So as Jorge mentioned, Hirose has been on the cutting edge of this FFC connector development for a long time. It means for decades we've been talking to some of the largest consumer electronics customers who would be using these connectors. And recently, in the past decade, we've started talking to various other applications that are not consumer electronics to also use this connector. So if you've ever bought a display, it might have a flex tail on it, and you might have seen how the display manufacturer is going to suggest a certain connector in their literature. But you can choose whatever connector you want, and choosing a specific connector for your application can be challenging depending on your application. So this is the first type of lock type. After the consumer industry received countless failures and quality issues due to low insertion force or lift connectors, the more reliable drawer stuffer on the screen was developed. But even though the cable doesn't fall out as easily, it's difficult to assemble these drawer stuffers. You need to hold the cable on both sides with your index fingers and thumbs, and then you need to hold that steady while you bring your thumbs around and push the lock over the cable. We call this a freehand operation because it's kind of frustrating, and you can't always get it on your first try. So this is the most common. It's the front flip. As mentioned, Hirose invented the flip lock ZIF connector around 25 years ago, and it remains the best way to lock flex cables to a piece of.
Do all this.
The animation on the screen showing how the front flip works. You push the cable in, flip the lock towards the cable, and that causes the cable to be pinched and secured in place.
So you're gonna go on.
Next slide, please. And this is the back flip. Okay, so as you can see from this animation, rather than the actuator directly pressing down on the cable, the back flip lock use a lever-shaped contact. So it pulls up on the back end of the lever, and again, that pinches and secures the cable.
At least it go. I think.
So this is a new, exciting one-action lock type. It's still a backflip lock design from the previous slide, but with this lock type, you just insert the cable, upon which you're going to feel and hear a tactile click.
I'll push the button. That. Absolutely.
And so now we have a video. I don't know if it's going to work, but if it does work, this person is connecting 5 cables in under 10 seconds total.
Look. Now.
Right, so very quick, easy to make a quick video because it's pretty easy to mate and unmate.
Right. See.
So many customers have bigger applications and they want to use flex connectors for one reason or another, but they don't want to sacrifice any durability when they switch away from the wired connectors that they were using. These 2-piece connectors on the slide, they're meant to handle extreme shock, vibration, and generally untrained glove cover canards. So they can replace a wire to board connector without actually being any less durable, maybe even being more durable.
Thank you, Kerry. We're going to start now diving into some of the concerns on the conception. The first one is application. That this is only for display. Next slide. Jade, tell us a little bit about the various type of FFCs and the evolution of them.
Sure. Yeah, the FFC on the far left is what you would expect the traditional FFC to look like, just the straight, straight-walled cable that you would plug into that drawer type of connector. Some time ago, you folks invented these connectors that now accept cables with the locking tabs, which you can see in the middle, a little bit hard to see. You can see them a little bit better on the far right cable. And that cable not only has the locking tabs, but also has a ground plane layer and allows us to create an impedance controlled cable.
Yeah, thank you, Jay. And we'll be talking about that in a future slide. Tell us about some of the changes you've seen, some of the things you can do now.
Yeah, certainly. I mean, we do interconnects for all sorts of industries. As I said, some of the things that are shown there go into night vision goggles, some GPS modules, some remote sensors, and also that bottom one is a hybrid display type of connector for an SVGA display. Yep, what we see there again on the left is the fully impedance controlled FFC with both the locking tabs and the ground plane. And then the one on the right hand side, the similar cable construction has tabs and the ground plane, but it is pre-installed to an FPC to board connector.
Okay, cool.
Yep, I think some of these the applications that we've been involved in, as you see there, IV pumps, surgical glasses, and defibrillators, and it's important to note that a couple of those devices can have the mixed technology. They can have FPC and FFC in there.
Jay, can you tell us one of your most challenging applications?
Yeah, so we deal with a lot of medical devices that require a significant amount of flexing and cable routing. So we've done some mixed technology where we've preformed cables, and we have to ensure that, much like those glasses, that they withstand hundreds of thousands, if not millions, of flex cycles.
Liam, tell us a little about where these connectors can be used.
Sure. Yeah, in my experience in the field, across all of the different industries and applications listed here, FPC connectors were and still are a staple product for display connections, but now they're being used for much more as well. So some of the reasons for this is their ability, as Jay mentioned, for flexible cable routing, the fact that they're very lightweight, and also slightly mentioned before for their high-speed capabilities. And I'll touch on all of these points in the following slides.
Yeah, and I'd like to add that we have direct experiences talking to customers in these applications.
Okay.
Continue, Liam.
Definitely, yeah. So I worked with a lot of these customers myself, and a new place or kind of an interesting environment where FPCs are starting to become a staple is actually battery management systems and large battery modules. Traditionally, very complex discrete wire assemblies or small PCB module controllers were used to link all of the modules together. But now FPCs can be printed to specific layouts, and they can also handle the high temperature environment to make a more compact and more cost-effective solution. And so these are some actual photos from the field. And so you can see in the left photo that many discrete wires are routed underneath the gray plastic. And then in the right photos, all of that plastic is actually removed, and you get a much more consolidated FPC assembly routing all of those modules together. So it just much more simplifies the actual cable assembly and manufacturing process of the modules.
And not only that, we know in battery management system, you want to dedicate most of the volume for the actual cells. So every time you can reduce the size of the PCB, the cable, the connectors, your energy density increases.
Yeah, so another area where I have a lot of experience is within humanoid robotics. So I work directly with some of the leading companies here in New England. And within these designs, there's a lot of unique design challenges, especially around things like the joints, because you need very high density, high speed connectors that are also very flexible. And mostly because of the size and their density, I've seen FPC connectors used in these applications quite a bit and throughout the entire robot.
Oh.
And then another interesting place is within vehicle and automotive applications. These have always been difficult since there's strict safety guidelines and need for very high temperature and vibration resistance. And this is definitely important since these connectors are used in very vital points where ultimately people could die if these connectors fail. So even in these very critical conditions, I've seen ZIF connectors starting to be used for things like sensors, obviously things like display interfaces, but even more vital components like headlights, ZIF connectors are starting to make their way into that space as well.
All right.
Another point where I've had a lot of experience is, and another cool feature of FFC and FPC connectors is sometimes they can increase design flexibility. So something that I've seen that's sometimes overlooked is the actual assembly once the design is finished. And so in this situation, this was with broadcasting equipment. The customer needed a high-speed FFC or a high-speed board-to-board connection, but by using FFC instead, they were able to connect the boards before the assembly process, make sure that they're connected properly, and then flip the PCBs on top of each other, which just made the entire process much easier, but also still gave them a low noise, high-speed connection between the boards. And then the last application I'll touch on is with cameras. So the main thing I want to point out is the sensor module on the right. It's very common for the sensor suppliers to just have a kind of loose FPC hanging off of the module to integrate to your PCB. And this just makes a very easy connection since FPCs and ZIF connectors are so standard. It pretty much means that any connector that's the same pitch and uses the same thickness can be used to integrate it to your board. So it just makes them very easy to use for engineers when designing in the sensor modules as well.
Thank you, Liam. We're going to talk about the second bucket, probably perhaps the most important one, that this connector is not robust and not reliable enough for design when you factory, when you build your PCB.
It's fine.
So
That's yeah. Good.
So Nira, walk us through this slide.
Yeah. So as Jorge mentioned, FPC retention is something that's a misconception that it comes out too easily. So on this slide, I wanted to highlight how robust the FPC retention can be to the board with the connector. So I'm highlighting the first connector is a connector with no side tabs. And when I say no side tabs, that means no ears on the FPCs. On a 6 pin, the retention is close to 1 pound. But if you add side tabs, just little ears on that FPC or FFC, you can increase that retention to almost 4.7 pounds of force. That's equivalent to almost half a gallon of milk. So you can significantly increase your retention by adding small side tabs on your flex. Honorable mention, we went over some of the latching connectors earlier. So those positive latching flex connectors are being compared to like wire-to-board connectors. And if you look at our wire-to-board comparison or a friction fit toward with an FPC latching connector, now those are more comparable at 22.5 pounds of force for the latching flex, and then 16.4 for the friction fit wire-to-board connector. So yeah, it's pretty high.
Yeah, thanks, Niral. And if we exclude the two-piece connector, the regular ZIF connectors are obviously not as strong as your wire-to-board. And we don't pretend to say that either. But the retention force may be sufficient for most applications. And also, let's remember that the flexible wire doesn't carry much weight. So any dynamic forces would be much smaller than using discrete wires.
Yep.
Let's switch to manufacturing now. Kerik?
Yeah. So as Meryl mentioned, adding retention tabs to the cable can drastically increase retention force. You can see we have the ×4 retention on screen. Since this is super common, flex suppliers like Miraco can provide tabs on the end of the cables with pretty minimal extra cost. It's just a die punch tooling.
Not really. Yeah, we do. Yeah, but
So contact types, unlike competitors, Hirose's contacts are stamped and then they're injection molded within the plastic resin of the housing. This allows various contact shapes and tighter dimensional tolerances. In environments with intense vibration or dust intrusion, contact redundancy like this is greatly appreciated by our customers who are looking for long-term reliability. So here you can see a more detailed picture of how there's 2 redundant contacts touching each conductive pad on the flex cable. Next.
bad. Yep.
And let's get past this one. And this one. So so there's more pictures of the 2-point contact connectors. 2-point contact connectors are available in all the different lock types. We're showing different lock types on the screen right now. But regardless of which type is used, each of the 2 contacts are a different length, which means they have a different natural frequency. There's no resonance issues. That's another small benefit.
Yeah, that's an important point. So when things move, when you have the 2 points of contact in the same pin, they move together. Here, because they are separate pins, they move independently. So that increases reliability.
But Linux is not good.
So now talking about the connection to the board. In the retention force table that Neural was showing, all of those connectors eventually failed due to the retention tabs breaking, or if there weren't any retention tabs, the cable slipped away from the lock. The reason those connectors didn't grip the connector off of the PCB is because of the feature shown on this slide. Hirose's flex connectors have robust mechanical solder pins on the sides of each connector, so even if a large force is applied, the connector remains on the PCB and none of the signal pins end up being bent. Pretty much retention involves both the cable to the connector and the connector to the PCB.
Never. Yeah.
During reflow, it's important that solder is used to connect the contacts to the PCB rather than wicking up the contact and into the connector. This would, of course, take the solder away from where it's needed on the PCB and into an area where we don't want it. To prevent this, Hirose selectively plates each section of the contacts with gold or nickel in order to streamline the reflow process. Speaking of the reflow process, copper traces on the PCB oxidize when exposed to air, which is why we use flux before soldering to remove the oxides and protect the solder from the air. However, those same properties that make the flux good for wetting the PCB can also cause it to climb up small openings, if they are there. If low viscosity liquid like flux encounters a narrow tube, surface tension causes the meniscus to curve, which pulls the liquid up the tube. Besides taking flux away from where it's needed, flux residue inside a connector can end up degrading voltage insulation and signal integrity. It can cause corrosion, and it can generally harm the long-term reliability. All of this is just to say that Hirose understands the reflow process, and our connectors have wide enough spaces to avoid the flux climbing into the connector.
Yeah. Thank you, Eric. And when we talk about robustness, it's not just for the performance. It can get from manufacturing. So for the design, when you talk to the manufacturing person, let them know that we understand at Hirose how to help to read their issues. Now we're going to talk about assembly. Okay, so you build a PCB. Now you need to connect the cables. There's some problems, concerns, misconception. Let's go through them. Next. Eric?
Yes. So one of the most common ways to use FFC is to cost-effectively connect 2 PCBs, as shown on the left. However, if the contacts are on one side of the cable when you insert into the top board, then those contacts are going to end up being on the other side of the cable when inserting into the bottom board. So in order to use that same connector on both PCBs, the connector has to have contacts in both the top and the bottom of the cable.
Yeah.
Which it does in this. When measuring the retention values in Neural's cable from before, we pulled the cable horizontal. However, if the concern is actually pulling the cable vertically upwards, then a front flip block will actually easily be flipped open by that upward pressure, while a back flip block can remain secure regardless of direction of force.
Yeah, so the selection of the connector is part of the design, but also has to do with how it's going to be assembled in the factory.
Often customers are measuring the cost of the connection by how much they pay for the connector and the cable, just the cost. But the point of this slide is to show that after the connector is purchased, there's various other places that you can increase your costs if you're not careful, such as damage during assembly. Single action connectors are not damaged during assembly because there's no need to flip the small latch open or close. And then later during shipping, the connector is much less likely to be damaged because the lock is closed during shipping, which means the lock isn't likely to be smashed or break off. And then later after that, the technician assembly time is reduced, regardless of if that technician is a human or a robot.
Yes, in an earlier video, we showed how easy it was to assemble these one-action connectors. I myself broke, while trying to fix my computer, broke one of these connectors because I didn't know how to flip the actuator to the front, to the back, and I broke it. the one action, one of the things customers like is they don't have to train people because they just need to push it. That simplifies their processes as well.
And then the one last benefit of the one action is that if you never need to open the lock, then you can place the connector in a much tighter space because you don't need to leave space above the connector to operate the latch.
Good.
Yeah. As I meet with a bunch of different customers, one thing I always hear is that they think they plugged in the cable, but then it falls out later because it never actually was inserted like they thought it was. To fix this common issue, Hirose places what we call windows on each side of the connector. If you look at the connector from above and the windows show the color of the connector rather than the color of the cable, then you know the cable's not fully inserted. Since cameras can see color better than precise distances, this enables even lower quality cameras nowadays to be used on the production line to check that the connector is fully made. So this connector is not really the type that's meant just for displays. Now that I'm sorry on the screen, this is the two-piece. They can be mated and unmated many times, just like a wired connector. And while customers typically use wired connectors to increase durability, these two-piece flex connectors can actually pass harsher vibration, shock, and retention testing than those wired connectors. In addition to that, you don't need to crimp all the wires. So you can see on the left, that's like maybe 30 wires you need to crimp, but the two-piece design, you just put the cable in, and then you snap in that retainer behind it, and you're done.
And not only you don't have to clamp every wire, you don't have to be careful about inserting the right wire in the right opening. So that simplifies assembly as well.
And you don't need to buy any quick tooling. So pick and place. This is kind of obvious. Most people know about pick and place, but that goes to show that customers, almost all of them, do use a pick and place machine to place the parts before reflow. So to accommodate this, all of Hirose's parts, of course, have a dedicated flat section that fits various pick and place dowels.
Oh, wow.
As everyone knows, Hirose sells a lot of extremely tiny connectors that you need your little magnifying glass to be able to see the connector at all. But that's not what this presentation is about. None of the connectors in this presentation require your magnifying glass or jeweler's loupe. The surface mount leads on connectors like the one in the picture can be clearly checked with the naked eye to make sure they're properly soldered, even without the magnifying use.
Thank you. Let's switch about cabling, how cables are made and how cables can help assembly. Jay, tell us about how you make cables.
Sure. We've adopted a lot of the same technology that we've used on flexible printed circuits in the past to build these new FFCs with the locking tabs and the tighter tolerances. As you can see there, we have a couple of laser systems, so we can do small volume and prototyping with lasers, but we also do use Class A punch dies to achieve those tight tolerances for mass production.
And you can maintain tight tolerances, correct?
Oh, absolutely.
Have you had ever any problem in meeting the Hirose specs for cabling?
No, none at all. We can even exceed the tolerances in some cases. So what you're looking at here are a few ways that we help our customers make installation into their chassis easier. On the left is simply a flexible printed circuit that is manufactured in the L shape. The one in the center picture is one that forms more of a three-dimensional shape. Once the main board is put down, those arms are then routed across the chassis. And then with the FFC cables, we're able to pre-fold and form those for you.
Yes, the pre-folding is very important. If the customer tries to fold it themselves, it will be a nightmare. So I'm glad that you guys can provide that service.
Absolutely. Along with the folding and forming, we offer several EMI shielding options. On the left is a sketch of a typical aluminum with the aluminum foil wrap with a PET overlay. So it is an insulated foil shield. In the middle is indicative of our sprayed on silver ink shielding, which we also insulate with a conformal coating. And on the right, we can put a single layer ground plane aluminum with, again, PET overlay to make those impedance controlled cables.
Thank you, Jay. And we're going to talk about our last bucket, the type of features that a connector like cable can provide that may not have been available a few years ago. Liam?
Yeah, so this has to do with what Jay was just mentioning. But a new feature that we've included on some of our connectors is alternating or grounding contacts within the connector. And so these are built into the connector. And if we can go to the next slide, Jorge. You can see this is an actual image on the left from our FH41 connector. But as Jay was mentioning, essentially there is a grounding plate right underneath all the signal contacts. So all of those grounding contacts can then terminate to that grounding plate, which give you a really nice low noise connection. We also have extensive test data. So for some of our connectors, we have quite a few connectors that we've tested up to PCIe Gen 4, 16 gigabit per second high-speed transmission. But for pretty much all of those connectors, we have a lot of test data. And if we go to the next slide as well, pretty much anything that is needed, if you have a request for us, you can reach out and we can provide all these test reports as well. And then this is just a nice comparison, seeing going from a standard FFC connector without any of those grounding plates, and then moving to another connector using those grounding plates in a shielded FFC, the actual noise reduction you get from that transition. And then the other place that FFC or FBC connectors I've always struggled is that with their very fine density or their high density fine pitch, they're traditionally known for just single connections, just very low current signal. But something that's a little bit more recent is on some of our newer connectors and in the industry, you're starting to be able to leave a little bit more space for traces down the sides of the connectors and also run power down the sides of the FBCs as well. So this is mostly exclusive to FBCs rather than FFCs. But with this option right here in the middle, this is a very small connector that can do around 2 amps of power in and out. And then on the left, we even have options that can do 2 pins of 6 amps each, so up to 12 amps in and 12 amps out. So also power through these connectors as well.
Wow, 12 amps. So clearly, yeah, clearly this is not your father's ZIF connector.
Yeah, that's correct. It's we're taking a step, into some other connections where these haven't been used traditionally. So definitely not how they've been seen in the past.
Well, this concludes the main body of our presentations. We've gone through a journey, and you can see the ZIF connectors have evolved and offer features that were not available earlier. I hope we have addressed most of your concerns.
Right. Yeah.
I love product development. I have been involved designing fixtures, designing the equipment and devices all my career. My name is in several patents. But innovation is both exciting and risky. And engineering manage the risk through DFMEAs, PFMEAs, pilot builds, control introduction, prototypes, etc. With Hirose, we can help you mitigate and reduce those risks. So please reach out to us. You most likely will be talking to some of the people who have been presented today.